Dear students, in today's class we will learn about gravitational constant. This gravitational constant is also called universal constant. It is denoted by a capital letter G, as you can see here. So in the year 1798, it was in the year 1798 AD that a scientist named Henry Cavendish carried out an experiment in which he took two objects, each of them having mass 1 kg. He took two objects, one object was 1 kg and another object was 1 kg, and he placed them at a distance of 1 meter. That is, the distance between their centers were 1 meter. And using a very sensitive device, he calculated the force of attraction between them, and it was found to be, and when he calculated the force, it was found to be 6.67 times 10 to the power minus 11 Newton. And this value was taken as a gravitational constant. Not the unit, only the numerical value was taken as a gravitational constant. So the gravitational constant is, the value of gravitational constant is 6.67 10 to the power minus 11, and its unit is Newton meter square per kg square. Okay, once again I repeat. So it means that when 1 kg mass and another mass of 1 kg are placed at a distance of 1 meter, that means they are placed 1 meter apart, then there develops a force of attraction between them, and this force of attraction between them is a very weak force. As you can see, it's 6.67 times 10 to the power minus 11 Newton. It's a very weak force, very small force. So it can be calculated using only a very sensitive device. So that is what Henry Cavendish did in the year 1798 AD. So he found out the value, and this value is used as the value for gravitational constant. Here we have the definition of gravitational constant. It says the force of attraction that exists between two unit masses separated by unit distance is called gravitational constant. It says the force of attraction that develops between two objects, each of unit masses. Unit masses means 1 kg. So we have two masses, so we call it unit masses. Unit mass is 1 kg, and here we have unit mass 1 kg. So we have two unit masses, and the distance between them is 1 meter. We call it unit distance. So the force of attraction developed between two unit masses when they are separated by unit distance, then the value of that force is called gravitational constant. Are we clear here? Okay, let's go one more time. So when we place two objects, each of 1 kg and 1 kg, keeping the distance between them 1 meter, there will develop a force, and that force will be called gravitational constant. And the value, I told you earlier, it was 6.67 into 10 to the power minus 11 Newton. It was 6.67 10 to the power minus 11 Newton. The value will always remain the same. It will never change if the masses are each of 1 kg and the distance between them is 1 meter. Whatever may be the object, if the masses and the distance are in unit, then the force of attraction between them is always going to be 6.67 into 10 to the power minus 11 Newton. So this is the definition of gravitational constant. As I already mentioned, Gravitational constant is also called universal constant. But why it is called universal constant? So here is the answer. G is called universal constant because its value remains the same anywhere in the universe. Its value does not change. It remains the same anywhere, as it is not affected by the shape, size, and nature of the object and other physical conditions such as temperature, pressure, humidity, density, gravity, many more. So it is not affected by any of this. It means that if you take two objects, it could be of any shape. It could be two sphere, but the mass should be 1 kg each. And the distance between them be 1 meter, and the force of attraction between them will always be, it could be triangular shaped, it could be any shape, because the shape does not affect it. The value will remain the same. If you carry out this experiment on the Earth's surface, or you carry it on the Moon's surface, or you carry it out on the surface of the Mars, anywhere in the universe, the value will come out to be 6.67 times 10 to the power minus 11 Newton, as it is said by the great scientist. So that is why it is called universal constant. Here I have written the SI unit of G. Here the capital letter G denotes, I already told you, it denotes gravitational constant, yes, or universal constant. So now, how can we derive the SI unit of gravitational constant? You can derive the SI unit and the CGS unit. Let's try. Okay, as we know, the force of attraction between any two objects is given by the formula F equals to G m1 m2 upon d square. Now since we have to find the unit of G or derive the unit of G, we convert all the physical quantities into their unit. Now say force. The unit of force is Newton. We have here G. G is a physical quantity. We have to find its unit. So we don't know what its unit is. Newton is the unit. M1 is the mass. The unit of mass is kilogram. And again we have M2. It is also mass. The unit of M2 is also kilogram. And then we have this square, distance. The unit of distance, SI unit is meter. So we write, since it is square, it has a square, so we write m square. Now we isolate the gravitational constant from the units. We keep it separately from the units. So we bring all the units on the one side and place the gravitational constant on the other side. So it becomes, when it comes to this side, it becomes 19 Newton. Sorry, I said 19 Newton times meter square, and kg times kg will give you kg square. And here we have gravitational constant, and then it can be written as G equals to Newton meter square upon kg square, which can be written as Newton meter square per kg square. So this is the unit of gravitational constant. This is how we derive the unit of gravitational constant. Practice it. Have a good time. See you in the next video.